Hi, welcome everyone. In this video, I'm going to show you another feature of EViews that can be applied on time series and even on panel data. This function lets you to extract a random version or random changes of the variable, the unpredictable portion of the variable. So EViews calls it whitening. So let me open a variable. Let's say I will open up this variable. So this variable, if I show you some details, so if you go here in the proc and you see the seasonal adjustment, you will notice that it has some seasonal means and some remainder means. So this is the portion of the variable which is unexplainable because of the trend or the season. So it means there is something there for some portion of the data which is not explained. So we need to extract that portion. So what we'll do, we'll open up the data. We want to extract the unexplained portion. Why? Because sometimes we need a random version of the random portion of the variable which is not correlated with other variables, or sometimes it helps us to avoid endogeneity. Sometimes we need to use it as an unexpected change of the variable, because the non-random one will be the expected change and the random one will be unexpected change. So what I will do, I will open up proc and go make whitened. So other people, what they usually do is they create a AR1 equation like dependent variable as an independent variable is the lag of dependent variable, and then pick up the residuals to make a Whiten series. That's the one of the most basic method to do it. Second way that EViews does is that you select the AIC method. It will select the appropriate lags based upon the level of significance, and then you can store the residuals, you can store the coefficients, so output of that variable. So what I will do, it will store as the Whiten series. So when I do it okay, it will show me, and now it's only showing three values because it has used 1 2 3 4 5 6 7, it has used 6 lags. So the more lags it uses, the more values it will not be able to show. So if your data is small, you can fix the maximum lag to a lower number, maybe 1 or 2. But this is just an example where you can create a series. Now you can see the coefficients by closing it, then open up the coefficient. Where is the table where I stored it? Let me find it. Output cat, yeah. So there are, this is the intercept and these are the slope coefficients of the model. Now we can compare the cat variable with the Python series, and open as a group. Now if I check for its correlation, technically it should be very low and it's almost zero. So what does it do? That technically, if I go for the graph, if I want to make a graph of medians and if I want to make a line chart, so you will notice that there is no comparison. If I add more details in it, like if I go in axis scaling and if I move it to the right and overlap it, you will notice that it's just a random change portion. Okay, so there is a change and it's a very small change as compared to the change of the actual variable. But what does it do? That this change is unpredictable based upon the past changes of the independent variable. So this is one way that you can create a random portion of a variable. The function name is whitened in EViews. Thank you very much for watching.